Hi, my name is Joe Hawking, and welcome to this third and final video in the mini-series on the fundamentals of how computers operate. Final for now, anyway. There's certainly a lot more to learn about how computers operate, but these couple of fundamental concepts were the main ones I didn't see being covered elsewhere, and that's why I wanted to record these. Anyway, in this video, you're going to be learning about electronic switches. In the last video, I showed how logic gates work, and in making them, you saw me using physical switches like this one that I had to, push with my finger. Physical switches like this are certainly the most familiar switches to most people. However, obviously, tiny little, computer microchips don't have, physical switches on them. So instead, they have what are called electronic switches. Much as physical switches require you to actually push on them to make them flip on and off, different kinds of switches actually take different kinds of inputs. You've probably seen, for example, switches that respond to sound, like the clapper, you clap and then it turns on. There are switches that respond to, motion detectors. Well, there are also switches that flip on and on based on whether or not there is electricity going to the switch, and that's an electronic switch. All right, so there are three main kinds of electronic switches: relays, vacuum tubes, and transistors. Computers in the past have been made with all three of those. There have been computers made with relays, there have been computers made with vacuum tubes. However, all computers these days, all modern computers, are built with transistors.
Transistors are made of a special kind of material called a semiconductor, and silicon is the main semiconducting material. If you're curious about the physics, then there are links in the description. But basically, layers of specially prepared silicon result in an electronic switch.
Alright, so now I'm going to demonstrate how to wire up a transistor. And this over here, this is a transistor. The fact that the prongs are spread out, I just spread them out to make it easier to clip onto. Normally, when you just buy a new transistor, the three prongs are going to be right next to each other. But anyway, a transistor has three prongs. This, unlike an LED, whereas an LED just has two prongs, the positive and negative side, a transistor actually has three prongs. The two prongs, two of them are just like in any switch, the wire that you're connecting together, that you're controlling through the switch, just uses two of those prongs. But then the third prong is actually power from an outside source, and that's what's controlling the transistor. All right, so to demonstrate how a transistor works, first I created these two separate circuits. These are just, pretty simple circuits. There's just a switch in the middle and an LED. So, the switch, when the switch turns on, the LED turns on. Switch is off, LED turns off. Same on the other side. I just have two of those. You can see, switch, switch. Not complicated. Right now, however, these two circuits are completely separate from each other. What I'm going to do is replace this switch and this output, this LED, and I'm just going to use the transistor. And thus, the output from this circuit is going to go into the transistor, and the transistor is going to be a switch in this circuit. So let us do that. Let's get rid of this switch. Plug the LED on. And then meanwhile, I'm going to get rid of this LED. So it's no longer going to output to this LED, and instead it's just going to plug into this transistor here. So. And if I've done that right, then now when I flick this switch, that'll control that light. And you can see, when I flick the switch, the light turns on and off. Now, it might look initially sort of like, well, gee, that's not earth-shattering when you flick a switch on and off that controls the light. But you'll notice I'm controlling it indirectly. This switch controls this circuit, the circuit made with the yellow and green wires. Meanwhile, the LED is being powered by this circuit, the circuit made with the yellow and with the red and black wires. And the connection point between these two circuits is just this transistor. This circuit just controls whether this transistor is on and off. And then this transistor is a switch which controls this LED. So that's what's happening here. So that's how transistors work. You've seen how electricity can be used to turn a switch on and off. In the previous video, we had seen what are called logic gates. So you saw how different patterns of inputs can control what is output, and those inputs are switches. So hopefully you can put, sort of two and two together, put these concepts together, and realize that like the output from a logic gate can be one of the inputs to another logic gate, and thus you can have multiple logic gates hooked together. And that, in a nutshell, is how computers operate. All right, thanks.